Now, you will recognise this part here. First of all, here is the quadratic term, the x squared term. The heading says that we are dealing with a quadratic equation, so you haven't seen the equals 0 part before, but the equals is necessary to make it an equation, otherwise we just have a quadratic expression. And we'll be dealing with an equals 0 in all of these questions in today's lesson. So what do we have here? We have two terms and 3x is common to both terms. So I'm going to take out 3x as a common factor. Now 3x times what would give me 3x squared? 3x times what? Well, this must be an x here. The sign is not going to change. And what do I multiply 3x by to get 6x? I'll multiply by 2. So I've factorised by taking out a common factor. So what is new is that we set 3x equal to 0. We set the first factor equal to 0. And then we set the second factor equal to 0 as well. So x minus 2 equals 0. 3 times what equals 0? 3 times 0 equals 0. So x must equal 0. Now if I add, this is a very simple linear equation here. If I add 2 to both sides, I get x equals 2. So that's what's called solving a quadratic equation by factorising. And this first example involves the common factor. Now, what the relevance of these points is, we'll leave that for the next lesson. Here's the second example. Now, this is a bit strange. This is not in standard form. Here is our squared term, so we know it's a quadratic. We have an equals, so we know it's a quadratic equation. But we should really, in all of these quadratic equations, if we're going to solve them, have equals 0. So what I'm going to do is to get this 4x term over beside the 5x squared, and I can do that by subtracting 4x from both sides. So 0 equals 5x squared minus 4x, and I might want to turn it round and write that as 5x squared minus 4x equals 0. So that's now in standard form. We've got the x squared term, the quadratic term, this is the linear term, then equals 0. Now I can take out x as a common factor, and that will leave me with 5x minus 4. Then I'm going to set x equal to 0, and I'll set the second factor equal to 0 as well, so that's 5x minus 4 equals 0. We don't do anything more with this, this is finished, but we have to solve this. So what am I going to do? I'm going to add 4 to both sides. 5x equals 4, then I'm going to divide by 5, so x equals 4/5. That's a bit awkward, but it's perfectly acceptable and correct. Here's the third example. Now, after your revision of factorising, I hope you can see that this is the difference of squares. So it's a quadratic equation. We've got the equal sign and the 0. So if I factorise this, it's going to be x and x, 5 and 5, because 5 times 5 gives me 25. And remember, when we have a difference of squares, we have one bracket with a positive and one with a negative. So what I'm going to do is to set the first factor equal to 0, x plus 5 equals 0, and then the second factor set equal to 0. We've got two simple linear equations here, so I'm going to subtract 5 from both sides. We want to get x on its own, so x equals minus 5. But in this one I'm going to add 5 to both sides, So x equals plus 5. Example 3, another difference of squares. I think what we're going to do is maybe just rewrite this so that we can see the squares clearly. So what do I multiply by itself to get 4x squared? I multiply 2x by itself. What do I multiply by itself to get 81? I multiply 9 by itself. So we can now see that there are two squared terms. Brackets. So we're going to have 2x at the front, and we'll have 9 at the back, and we have different signs in the brackets. Set each of the factors equal to 0, and then solve. So I'm going to add 9, 2x equals 9, then divide by 2, x equals 9 over 2. Here I'm going to subtract 9, so 2x equals minus 9, and divide by 2, x equals minus 9 over 2. So that's me factorised and solved the quadratic equation.